Hello guys, today we are going to discuss about the hierarchical methods topic. See, what is this hierarchical methods means? A hierarchical method, this is a one type of clustering technique where we are having the two different types of approaches are there. That is agglomerative hierarchical clustering is one approach and divisive hierarchical algorithm is the another approach. See, what is meant by agglomerative hierarchical clustering algorithm? So in these agglomerative hierarchical algorithms, each and every data point, it is treated as a single cluster and finally it will tries to successively merge or agglomerate in the bottom-up approach process. In the bottom-up approach, it is going to follow the bottom-up approach process for the given two pairs of clusters. So how the hierarchy of the clusters is represented means a hierarchy of the clusters can be represented as the dendrograms or tree structures. So it is going to follow the bottom-up approach. So while we are going to consider the bottom-up approach, here each and every individual data point can be considered as the cluster and based upon the similarity, we will merge the two different data points and finally until we get one singleton clusters, we use it to do the merging process. And next one is the divisive hierarchical algorithms. What is this divisive hierarchical algorithms means? Where divisive hierarchical algorithms, it will follow the process of dividing one big cluster into the small clusters. So it is going to follow the top-down approach process here. It is going to follow the top-down approach process. See, let's see how this agglomerative, we can call this agglomerative divisive approach as the agglomerative nesting process. See, first thing is we have to calculate the similarity of one cluster with all the other clusters. Calculate the proximity matrix. What is meant by calculating the proximity matrix means nothing but calculating the distance matrix using the Euclidean distance or Manhattan distance or Minkowski distance. So consider each and every data point as an individual clusters and then we have to merge the clusters which are highly similar and which are highly close to each other. So recalculate the proximity matrix for each and every cluster and repeat the steps 3 and 4 until we get the single clusters. So this is the process of the agglomerative nesting approach. Next, see, in this particular diagram, we are having the two approaches are included here. So this is my, if you go in this particular direction, agglomerative approach can be implemented. And if you are going in this particular reverse direction, divisive approach can be implemented. So divisive approach, one more name is the Diano approach, whereas agglomerative, one more name is the AGNES approach, or we can call it like agglomerative nesting approach. So in the step 1, I am having the 5 objects are there. That is the A, B, C, D and E. See, all these 5 objects can be treated as the individual clusters. So what I am going to do here, I am going to merge these A and B as the one cluster. And based upon the similarities, I have merged D and E as the one cluster. And I have merged this particular DE again with the C here. So finally, I got the ABCDE as the one cluster. Okay, this is the agglomerative and the divisive approach of a given data points A, B, C, D, E. And how this particular algorithm, that is the divisive hierarchical clustering, can be done. So here in the initialization, all the objects stay in the one cluster here and the cluster iteration, how the cluster iteration can be done means, first we need to select the cluster and then we will try to split it into the two clusters. We will try to split it into the two clusters. Suppose if I am having this is my one cluster, I will try to split it into the two clusters. So the entire clusters can be split based upon the similarities until we get the leaf clusters and it will contains the only one object. I will try to split my clusters here. So this is the way how the splitting can be done in the divisive approach. Next one, how your tree structure can be represented. Your tree structure always can be represented in the dendrograms, which is commonly used to represent the process of hierarchical clustering algorithm. So for doing this representation of the hierarchical clustering here, again we will calculate the minimum distance, which is called as the D minimum between the clusters Ci and Cj value. So here this is the thing. So how the minimum will be calculated? Minimum distance will be calculated for a given point P, which will belongs to the cluster Ci, and for the given point P bar, which will belongs to the cluster Cj, that is mod of P minus P bar is the distance, minimum distance. And what is the maximum distance here? Maximum distance means we are going to calculate how much will be the maximum distance will be there between the 2 points P and P bar. And again, mean distance will be calculated between the two clusters Ci and Cj. And the average distance also will be computed here between the Ci comma Cj value. And binary, so here the dendrogram tree structure, the dendrogram tree structure can be represented like this. So it will shows us how the clusters can be merged or how that can be split hierarchically. So this is one level, this is the another level, and this is the another level of representation. So this is one cluster here, where this particular one cluster, I am going to split it into the cluster 9 and 10 here. Again, this particular cluster 10, I have split it into the cluster 4 and the 6. And again here cluster 8, I have been split into the 1 and 5. And again, this particular cluster 7, I have split it into the cluster 2 and the cluster 3. Right. This is the dendrogram representation. This is also one type of dendrogram representation only where, but here, instead of splitting, I did merging process here. So if you take A, B, C, D, and E, all these are the individual data points where I'm going to consider as the individual clusters. So based upon the similarity, I have merged these 2 points, that is A and B, and then I have merged the D and E. Based upon the similarity, I have merged again D and E with the C point again. And again, AB, it has been merged with the CDE. And finally, I got only the one cluster here. This is the another approach here. And how the clustering can be obtained means, suppose if you are going to cut this particular dendrogram at one point, we are going to get the two different clusters, so that I can represent this is my one cluster and this is my another cluster here. And in that agglomerative clustering algorithm again, how the process of merging can be done means using the three techniques we can do the process of merging. That is the single linkage, complete linkage, and the average linkage. So how the distance can be measured between the two clusters means, we'll see. See how the distance can be measured means this is my one cluster and this is the another cluster here. And this is my distance. How to calculate the distance? The distance between the two clusters can be measured here with the help of the Euclidean distance or Manhattan distance or Minkowski distance here. I can use any of my distance measures here to calculate the distance between the two clusters. See here, I'm having the three different types of techniques are there. One is the single linkage, and the another one is the complete linkage, and the another one is the average linkage. See, what is meant by the single linkage means between a pair of the clusters, whatever the shortest distance is there, that shortest distance will be considered here between the two clusters. That is called as the single linkage process. But if you go for the complete linkage, the distance from the between the one cluster and the another cluster should be equal to the greatest distance from any member of the one cluster. That means here we will find out the D minimum distance, and whereas in the this one complete linkage, we will find out the D maximum distance. D maximum distance can be computed here for the complete linkage. And here for the average linkage, we will calculate the D average distance between the two clusters here. So these are the different approaches. If you observe these particular diagrams here, this is my minimum distance in the single linkage, whereas in the complete linkage, this is my greatest distance or the maximum distance between the cluster A and the cluster B. And this is my average linkages between all the points. I have calculated the average linkage for the cluster A and the cluster B. And the centroid linkage means one point I'm going to calculate as the mean centroid or the mean value here. For this particular centroid, for this cluster A and the another centroid for the cluster B, I will calculate the distance here, which is called as the centroid linkage. These are the different types of merging techniques we are having in the hierarchical clustering algorithms. So thank you guys.